Okay, welcome back to this video series in which we talk about the different hyperparameters of training a neural net and the consideration we need to take when developing a neural network model. In this video, we will talk about the effect of choosing a batch size for training a model. When you are training a model, the batch size is usually dictated by how much memory you have available. Depending on the size of your model and the size of each data point, you choose a relatively large batch size. And here is why. During the training, a batch is fed to your network and the loss is calculated. Then the optimizer uses this loss and backpropagate the error. If your batch size is 1, it means that you show your network a single example and backpropagate the error loss. The other extreme is to show all the examples of the data set and then calculate the error loss and backpropagate. Each one of these methods has their pros and cons. When using a batch size of 1, since you are backpropagating the error more frequently, your network gets better quicker than when you feed all your data set to the network and then backpropagate. On the other hand, the more you do the backpropagation, the slower the training will be, as we will see in the example. There is another point to consider here. With a batch size of 1, a new example might be drastically different than the previous ones. Thus, the backpropagation may alter the network considerably. Ultimately, this will cause the network to oscillate around the optimal minimum error point and not settling down on it. In the other case, the loss of different weights could cancel each other out and lead to a less accurate result. The other way to set the batch size is somewhere in between, not as small as a single data point, nor as large as the whole data set. This approach is called mini batch and has the strength of both previous methods. In practice, you should try larger batch size if your GPU's memory has enough capacity. Now, let's see how the network approximate with different batch sizes. In this example, we trained the same model with 3 batch sizes, 1, 20, and 200. So let's run the code and see how it performs. Okay, the training is over, but before we see the result, please pay attention to the time that each one of these networks took to train. The first one with the batch size of 1 took almost 1.5 minutes to train, whereas the second one took almost 5 seconds, and the one with the batch size of 200 took less than a second to train. As you can see, the one with batch size of 1 has done a good job of estimating the function. This result may not generalize as our task is very simple. I will make other videos for tasks that are more robust and complex, and I will revisit these concepts there. So please subscribe to the channel and hit the bell icon to be notified when I publish new contents like this. The second model is not as good, but still good enough. The point here is that it took 20 times less time with more epochs, and given that same batch size, this network could have better result with less computation than the first model. The last model batch size was too large and the network estimation is not good. Yet the training time was 120 times less than the first model. It might be the case that more epoch improved the result with even less computation time compared to the second one. If you enjoyed this video, please give me a thumbs up so others can find it on YouTube as well, and subscribe to my channel for future videos.